Hey guys, it's Mr. Katz. I just wanted to walk you through how to solve literal equations. So hopefully before we teach it in class, you have a really good idea of what literal equations are, and then you can definitely solve a literal equation. So literal equations, first of all, I wanted to mention that it is chapter 3.8 in your textbook. So if you wanted even more practice, you can go in there and do some odd problems. So this is a regular equation. And when you have a regular equation, one thing we've been doing in class is we've been solving for a variable. But essentially, we've been isolating for the x so that we bring this down and get x equal to something. And I don't know, if you add 6 on both sides, you get 3x equals 16. So x is going to be equal to 16 over 3, or whatever the decimal is. So what you're doing is you're moving everything over and essentially solving for that variable. Well, that's really all a literal equation is. Except in a literal equation, you're not getting an answer for x or y or g or r. What you're doing, though, is you're solving the equation so that it's solved for that specific variable. So here, ax minus 4y equals rb, r times b, remember. We could solve this for x. We're not going to know what x is, but we can solve it so that we know in terms of x. So to do that, we basically want to move everything over so that it just reads, just like here, x equals. Now, you're not going to have a number on this side, but you are going to have a expression that will mean the same thing as x. Well, the way that you do that, I'm going to explain. It's actually just like you solve an equation. I'm going to explain it as a real-world example. One of the most important formulas that you're going to learn in physics or any science class is distance equals rate times time. That means if you take the rate or the speed and multiply it by the time you're going at that speed, that will then give you the distance. And I write that as d equals rt, distance equals rate times time. Well, if you knew the rate was 30 miles per hour, and the time was 2 hours, it's really, really easy. It makes sense why this would be solved for d, because you do 30 times 2, and you get d equals 60, or the distance you traveled was 60 miles. Well, what if, even though we know distance equals rate times time, you're given the distance, given the rate, but you're not given the time? Well, now this formula, while you can still solve for time, it would make a lot more sense if we can change this formula around so that it says instead of d equals, it says t equals. Well, I take my equation, and what I essentially do is I'm going to isolate the t, meaning I'm going to cancel out this times r. And just like when we've been solving regular equations, the way that we're going to get rid of times r is we're going to do the inverse operation, the opposite of times r, which is divided by r, because r divided by r will cancel out, and you're left with t. Well, you can do that as long as you follow the properties of algebra and divide both sides by r. Well, d divided by r, we don't know d or r yet, so we're just going to leave it as d over r. Well, now we have a formula that instead of being solved for d, it's solved for t. I'm just going to turn this around. T equals d divided by r. Well, now if I have the distance and I have the rate, I can just plug them in, divide them, and what I'm left with will be the time. And that's all solving for a literal equation is. Let me give you some examples. We just did this one where we divided both sides by r, so we already did that one. How about this one? What if I wanted to solve for a? Meaning I want to get everything away so that in the end my equation says a equals instead of r equals. Well, let's think of this in terms of what we would do if it was just a regular equation. So I'm going to leave the a there, but I'm going to give each one of these variables a number. So you can remember what we do if it was in numbers. So basically, I gave the y, I made it into a 4. I put the r as 26, and I left this as the x is 3 and the a is a. Well, how would you solve this equation? Well, the first thing you would do is start moving things over by adding the 4 on both sides. Well, we can get this negative y over by just adding y on both sides. Now, you can't actually solve r plus y, but you can leave it as r plus y. We don't know what r and y are, so we're going to leave it like that. Well, now I'm getting closer to solving for a. Now it says ax equals r plus y. On this side, it says 3a is equal to 30. Well, how do I get rid of that 3? Or in this case, how do I get rid of the x? Well, it's being multiplied. So I'm going to divide by 3 on both sides. Well, same thing over here. I'm going to divide by x on both sides. That'll cancel out on this side, and I'm left with a equals r plus y divided by x. And remember, this is a totally acceptable answer. You really, knowing that it's being divided by x, both things are being divided by x, so you could have written as r divided by x plus y divided by x, but I really think this is the easiest way to do it. And again, we just remembering how we solve a normal equation. We're doing the same thing, we're just using variables. And we've now solved this original equation for a. Here's another example. In this case, I want to solve this equation for, let's solve it for x. So to do that, we have to move this negative by over to the other side. So I'm going to add by. This would be like the same thing as if I had 3a on this side and I had 4 plus 2a on this side. The way that we'd get all our a's combined is we'd subtract 2a or add, depending if it was negative, on both sides. Well, that's all we're doing here. We're just moving this over. So over here, I notice that there's already 3by, and if I'm adding a 1by, on this side cancels out. I'm left with just 1x, or I could leave that as x. But 3by plus 1by, I can actually combine to become 4by minus r. And there I've solved the literal equation. So what I want you to do now, oh, wait, I'm sorry, we're going to do one more, and then I'm going to have you pause the video and do some examples. In this one, I'm going to go ahead and solve for x. So first, I'm going to move the negative ty over by adding ty. That brings the ty over to the other side. So now I have ax is equal to r plus w plus ty, or t times y. And I can't combine any of these. Last, I'm going to get rid of the a by, well, I'm canceling out the a. It's being multiplied by a, so I'm going to divide by a, which leaves me with x equals, as long as I do it on this side. And I'm going to divide everything by a, and there is my final answer, divided by a. And I've solved the original equation for x. What I want you to do right now is pause the video, and I want you to try each of these, but just so you know, the thing in parentheses means I want you to solve this equation for z, meaning make sure it says z equals at the end, solve this one for z, solve this one for r squared, and solve this one for r. So pause the video. And then when you're done, you could actually replay the video, and I'll show you the answer. So please pause the video now. All right, so for this one, you should have gotten rid of the divided by 4 by multiplying both sides by 4, which leaves you 4x equals 2y minus z. Then we got to move the 2y over, so it's a positive 2y. I'm going to subtract 2y on both sides. 4x minus 2y equals negative z. Now, we didn't want to solve for negative z. That's negative 1z. We want to solve for z. So I have to cancel out the negative 1 by dividing both sides by negative 1. Now, I'm going to do this right over here. So z on one side, you're left with z equals. Remember, both things get multiplied by negative 1. So when both things get multiplied by negative 1, they each become the opposite. So it was positive 4x, so it's negative 4x. And negative 2y divided by negative 1y becomes a positive 1y, or just positive y. And now I've solved my equation for z. Over here, I'm solving for z, so I'm going to multiply by 6 on both sides to get rid of the 6, which leaves me with 6x, because 6 times x equals yz. And then I'm going to divide both sides by y, and now I have z equals 6x divided by y. Over here, I'm going to solve for r squared, which means I'm going to leave both r squared is being multiplied by 4 and pi. So I could actually, in one step, divide by both 4 and pi, because look what happens. If you divide by 4 and pi and multiply by 4 and pi, it's going to cancel out and become 1. I'm left with r squared, which is what I was trying to be left with. And on this side, I have a divided by 4 pi, because you were dividing by 4 pi on both sides. And remember, you could turn this, this equation around and make it r squared equals a over 4 pi. That's the commutative property. You could switch them around, or you can leave it like this. Either way, you've solved for r squared. Here we're going to solve for r, so I'm going to get rid of the divided by n by multiplying by n. So p times n is just pn, or np, which equals r minus c. And now, to solve for r, I have to cancel out minus c, so I'm going to add c on both sides. And if I add c on this side, I'm left with pn plus c equals r. And that's how you do it. So go ahead and you could rewatch the video, but I hope that helps in figuring out how to solve literal equations.